Okay, welcome back. This is our final lesson on function notation, and we're trying to put it all into practice now. Good news is, it's no more theory. It's just using what you've learned so far about function notation and trying to solve real practical type questions. So let's have a look at this one. Let's zoom in a little bit closer here. We've got a L-shaped sort of block here that's got some dimensions y centimeters across the top. You've got 8 centimeters down the side and an x by x square cut out of the bottom left corner. We want to find an expression for the area in terms of x and y. So first part, look in the area of a composite shape. We can say, well, this total distance down here would be x plus 8 all the way down. And so my area would be x plus 8 times y, which gives the whole square, and then we're cutting out this bottom corner down here. So I'm going to be minusing x squared from it. So that's in terms of x and y. Doesn't look too dissimilar to what we've done in the past. Then we need to find an expression for the perimeter P in terms of x and y. So should be labeling my questions as well. There's A part I and part II. We've got the perimeter is going to be equal to, starting from the top, I've got y going around clockwise. I've got x plus 8. Down the bottom, you can see I've got y minus x. And then, so that's this one here, y minus x. And then I've got plus 2 lots of x plus 8 is my perimeter. So I can collect all that mess. I've got, what's it going to be? X plus 8 plus 2x is 3x. And then minus an x there, so I'm going to have 2x at my end. I'm just going to get rid of my brackets. Make it easier for myself. Click my like terms. So x minus x drops off. I've got 2 lots of y. I've got 2 lots of x. And I've got 2 lots of 8, so that's plus 16. Alright. If I wanted to, no, I'll leave it as that. So there's my perimeter and my area. So now let's look at part B. I've got if P equals 64, find area in terms of x. So perimeter, we can say 2y plus 2x plus 16 equals 64. Then I want to try and find area just in terms of x. So I want to have some function a just in terms of x. So what we can do is let's use this perimeter formula to try and find y in terms of x, and then I can substitute it in for this y in my area formula. So let's get y by itself. 64, I'm going to subtract my 16, and I'm also going to subtract my 2x, would give me 2y, and so y would be 32 minus 8 minus x, just dividing all through by 2. So I'm going to have y equals 24 minus x. So I'm going to take this 24 minus x and I'm going to substitute into my area formula. So my area formula at the top, I had x plus 8 times y, which I know is 24 minus x squared. So now I've got a formula for my area just in terms of x. Okay, so that is my part, that's only part BI. Right, find the allowable values for x. Okay, so this is where it gets a little bit different to what you've done in the past. So what's our possible values for x? We've got a in terms of x, and we can see this graph of the diagram on the side. We've got y minus x down the bottom here, and we can't have a measurement of 0 centimeters. This shape wouldn't exist or wouldn't look like it is. So therefore y minus x must be greater than 0. And also I've got, what else do we know there? Let's just do this one. So if I substitute in y, I'd have 24 minus 2x must be greater than 0. So if I minus my 24 over, I get minus 24 minus 2x, divide through by my negative 2, so x must be less than positive 12. So x can be between, now x can't be 0, can it? Because otherwise the bottle will drop off. So x must be between 0 and 12. So you can write it like that. Or x belongs to 0 to 12 if you wanted to. So that's our allowable values for x. So now let's sketch the graph of a against x for these values and what is the maximum area. So let's pull out our trusty CAS calculator. I'm going to clear all this junk. Okay, so what was my formula? X plus 8 times 24 minus x and minus x squared. So if we sketch that, let's zoom out a bit. Now we want x to be between 0 and 12, don't we? So let's put the restriction here, keyboard, and x. So let's go 0 less than x less than 12. Hit sketch, and you can see I've zoomed out to, oh, I've stuffed my zoom up here so I can zoom out. If you're ever in doubt and you can't find your graph, zoom out. Where are you? Oh, there you are. So zoom out more again. Alright, and if it looks really confusing, click this little magnifying glass, you can just drag to what your screen to look like. So it's a little bit better. Now, the other way you can do it, if you click this little window with the 4 arrows pointing to each side, you can actually type in what you want your axis to show. So I only want 0 to go, x to go 0 to 12. Hey, that's much better. Look at that. So there's our graph. I can go gsolve, find my intercepts, x, y calc. Now, I set it not equal to, didn't I? So I might have trouble here. I'm just going to sketch the whole thing here. Right, analyze gsolve, x, y calc. I want to find the y calc. So when x is 0, plug that in. I can see at 0 and 192. And analyze gsolve y when it's 12. Oh yes. Analyze gsolve xy calc at 12. There it is at 96. Okay, so on my sketch, alright, haven't finished yet. There's my sketch. It was at 0, 192, and that was terrible by me. It should be a hollow circle, and it went up, and then it came down to 12. Was it 90 something? 96 maybe? Yep, 96. So that's our sketch. And to find the maximum on your calculator, right, analyze, we want to solve for the maximum. We can see it's at 224, so why can't I zoom out here? Zoom, yeah, there it is. So analyze gsolve, yeah, maximum, and it just gives you the maximums on the screen, so make sure you can see your turning point at the top there. So it's at 224, and that's when x is 4. So at that point, you've got 224. So That is your maximum area. Therefore, the maximum area is 224 and occurs at x equals 4. Okay. Now, I'm hoping it's just a matter of practice in terms of putting this in here, but we're just trying to set up a similar question that you would have done in the past, but just giving you the notation that you to set out your working out. This second part of it here, you wouldn't be expected to do that by hand. This would be a tech active type SACA exam question. Okay, all the best with exercise 5H, and then we'll jump to some revision.